Mr. Shivam, can we start?
Yeah, sure. Yeah. Let me know when my screen is visible.
Just 1 minute. Good afternoon, everyone. Mr. Shivam, can we start? Yes, sir, we'll start.
Yeah, sure. Yeah. Let me know when my screen is visible.
Just 1 minute. Good afternoon, everyone. Mr. Shivam, can we start? Yes, sir, we'll start.
Yeah, sure. Yeah. Let me know when my screen is visible.
Just 1. Yes, sir, your screen is visible.
Okay. Shall I start?
Yeah, just 1 minute.
Sure.
Good afternoon, everyone. So we'll start with our post-lunch session on big data. So we have Mr. Shivam Somani, and later we'll Harshvardhan Bhosle would be joining us. We have Shivam Somani and Harshvardhan Bhosle are senior data engineers from Quantify, and they would be delivering session on big data. Over to you, Shivam, sir.
Thank you, sir, for the welcome. Yep. Hello, everyone. Good afternoon. So I hope you all enjoyed the session before, like on the cloud technologies, and yeah, so we'll continue with the big data technologies in this session. I'll briefly walk you through all the pointers we are going to cover here in the big data session. So basically, we'll first talk about what is big data, the introduction, how it is important to us, and what are the challenges there. And then we'll talk about like Hadoop, how Hadoop, SDFS or distributed system solves these challenges and problems we had with the big data. And following with, we have a Hive ecosystem session, and then after that there will be a Spark ecosystem session. Yeah, so let's talk about like the introduction to big data and Hadoop. So in this particular session, so we'll be covering what is big data and what are the driving growth, what is driving the growth of big data, and the different domains of big data, like from which domains or which all domains the data is generated and all, and the problems or challenges with the processing of big data or storing the data, and the big data solutions. Yeah, so what is big data? So everything in the current world we do generate some data, right? So it all started in the ancient time there were so in the ancient time there was a like tablets were there when ancient people used to write their text or diagrams in their tablets, and then in the traditional world we have file systems where files are stored in like a paper-based manner, and then we had internet and everything comes on online, and now we are generating a lot of data. For example, like Facebook generates 500 terabytes of data per day, and there are a lot of things like let's say stock market. So if you know, like there are millions of transactions or billions of transactions happens on a single day in a stock market. So every transactions are being recorded as a data in some or other systems for regulatory purposes or for other analytics purposes. So there are a lot of data that is generating, and like once we had electricity, internet, all the things we had. So since we had more means of communication, and now we are generating more number of data. Yeah. So basically, what is the definition here is big data. So data was present there. Why we call it a big data? So traditionally, we had all the data in the relational system, file-based system, and the data was like in limited number, not that amount that we couldn't process or we couldn't do it manually. So that data growth has been become a very fast, and now the data is so large and complex that it becomes difficult to process on hand database system tools or traditional database processing applications. You can see like there are a number of systems that it can be a social media, it can be a mobile, it can be IoT, and every like GPS systems, everything is generating a data, and a lot of data is getting generated like a mesh. So it becomes difficult to analyze this complex data and the huge amount of data. That's why this new terms come in like a big data. Yeah. So basically, what are the characteristics I would say for big data? So there is a concept of V's of big data, which tells about the characteristics of big data basically. So in the 5 V's, or you can see like there are 6 V's, or it may get more. So let's talk about them one by one. So let's talk about volume. So as I said, like data is generating as a very vast and fast speed. So volume is like in terabytes. Facebook is generating 500 plus terabytes in a day, and records and everything that we do on internet or anywhere. Like even if it is not an internet, you are doing something that is generating data. Yeah. So it basically the volume is that, and velocity. So velocity is basically there are data which is in batches, and there is data that is in real and near time. So basically whenever you click, sorry. So basically whenever you click on any website, let's say we go to Amazon and buy something, and we are clicking on any product, and we are just clicking on any product and adding it to cart. So every click you do is generating a data, and with that velocity it is generating data. So it goes into the backend and everything gets processed and stored with that velocity. So what value is that is generating with the big data? So basically, as I said, like when you click on any product and add it to cart, any on any online shopping or any other website. So basically, every clicks are stored in the backend, and they use that data or use statistics to generate values, like how many of the people which clicks and add the products into the cart are actually buying the product. So this can be the one use case that is generating value for their business, and accordingly they can they can also see like if there are 2 or 3 types of products that is that are to, and only one of them is being bought by the buyer. So they can see the analysis with the statistical analysis that this data is getting this product is getting bought many times, and other is not. So what are the features that is lacking in that product, and they can like do their due diligence to give that product more features, or even they use it to recommend them, like if they are buying more of one type of product, then like it will be recommended to you more basis. Then comes variety of data. So the data is coming into the various forms, like since we are doing a online virtual meeting right now, so it's generating a video frames, like image frames that is getting generated, and it's basically an unstructured data. Whenever like someone places an order or someone buy a policy on insurance, so that also generates some type of structured data, or maybe in unstructured data. If a policy document is like a document, not an record website, so it can be an unstructured PDF document, and there can be some JSON values, that there can be XMLs or HTMLs and all. So this belongs to variety of data. What is the veracity of data? So how trustworthiness is your data, is where it is coming from, what is the authenticity of this data, as I said, origin, so where is it is coming from, and what is the reputation of the origin, and what is the availability and accountability of that data. When you do a value analysis or a business statistical analysis, you must be uh, sure that it should be a trustworthy source of your data. Unless you be sure, then it can generate a wrong statistical analysis, and it can give you a wrong decision in your business. Then comes the variability, and that is basically the data is changing. So data, it is not fixed, and it is always be a variable. So it can be both ways actually. So there can be changing data, changing model, how data is being populated, that can change. So everything in like industrial worlds, if you say like in tech, every 10 years there is a change in technology and everything. So everything changes, a form of like representing a data, a form of generating a data, so that can be variable. Yeah. So what are the driving factors that is leading it to at that level, like it got a new name like big data? So basically, currently we have IoT devices. So I'll give you some example. Let's say there are autonomous cars that are being like known as generated, like created and built. So basically, they generate a lot of data. There are numerous number of cameras and sensors on them, and they actually on the real time generates data, and also send it to at the same time send it to cloud and do the action as well. So you just think about it, like how fast it is, just generating a data with a sensor is converting into actions in a milliseconds or seconds, because a car with an autonomous driver, so it shouldn't be lagging in any type of action if it sees objects or any things that is in the way of the car. Similarly, there are like health related apps. Nowadays, we have like bands on our hand, and everybody is walking in with their health bands and like fit bands, right? So everybody is walking with that, and everybody is generating like how many steps they are, each steps they are going with that. What is their heartbeats, and everything is generated with this health related data, and that is just because sensors and all. And this all data is then like pushed to cloud or any like data centers and all, and basically used for any actions or analysis or everything. Like this feedback data can be used by any healthcare service to recommend you some medicines, to recommend your diets or everything. Yeah. There can also when we come to security, like there is a vast number of increase in the video surveillance nowadays. So everywhere you can see the video cameras and everything. So you can also see this also presents some sensors as well. Thermal cameras that can be there. So everywhere there is a surveillance camera, and that generates a lot of data that is being analyzed and used critically. Yeah. Coming on to mobile devices. So as you can see, like it's sorry, yeah, it's basically a study from Cisco VNI Mobile Data Traffic Forecast. So what they did is they forecasted it for a 2000 from 2012 to 2017, how much data is growing with the with just use of mobile and what is the traffic of data. So you can see like it is going exponentially. The use of smartphones is increased exponentially. We are using laptops right now and for our virtual work, everything, tablets and other things. So it's growing terabytes in, like you can see it's more than like 12 billion terabytes, 12 million terabytes are there per month that are generated. Yeah. So you all, everyone is now on internet and using some or other kind of social media. So it can be WhatsApp or it can be Facebook. It can be everything. We are using. We are even using Gmails. If everything, Twitter is there. So everything you do with your mobile and you use social media, that is generating some kind of some other kind of data. So let's say currently we are also streaming this on YouTube. So we are kind of in 600 plus videos on YouTube that are going live per seconds. We are one of them. So that is like everybody is generating some or other kind of data in seconds or any seconds, minutes or days. So this is a lot of data that we are generating. So yeah, so I talk about like IoT, mobile devices, and so social media. So that we all in one or other way are aware of. So let's talk about how it helps industry domains to grow their business as well as their customers to provide a better product or values. So let's talk about healthcare. So as I gave you one example, like Fitbits are there, and everybody is like now having it in not if not Fitbit, then in their mobile apps that is there. So that they are counting the steps that you are taking, your heartbeats, your everything, and even you are like giving them the data like what height you have, what weight you have, and everything that you are giving them. These healthcare domain industries have their data from them, like sensors and everything, and also they have so they use that data also to give you a recommendation on diets and medicines and etc. Also, one of the main use case in healthcare is providing medicines and improving them basically. So whenever in healthcare, so there is a lot of research happens whenever a new medicine is created, like let's say COVID vaccine. So whenever a COVID vaccine is generated, it's been tested on various fronts, and it's been tested with the data as well first, and then only on the humans, right? So that helps in healthcare environment, like they build various vaccines and medicines on that front. In the telecom department, like telecom, so there are various antennas and all the things are there in the telecom. So we connect with the internet, and they use every much of that data to also like one of the use case can be they can see like which region of your like city or your state is not being it's not been connected with connected to as internet. So accordingly they can use GPS and all things to have a better location for their tower placements and all things. So they use in many ways. This is just one like scenario in insurance domain. So basically in insurance domains. Sorry, anyone saying something? Okay, yeah. So in insurance domain, like we have various platforms right now. So previously we used to only know the LIC and like the kind of trust we had on them in India, like mostly. So in insurance, that is like a boom when the data is coming, and they have like Policy Bazaar is having all the types of all the providers, and that is like having a more number of codes, more number of policies day by day. So what they do in the backend is like they analyze the data that is generating with the claims. So whenever some policies are generated in particular area, so that data is been policies are been bought by the customer in particular area. So how many of them are claiming that policies, and what is the claim percentage of that particular area? Let's say the policy is for let's say the policy is for our destruction of home or fire at home. So they can analyze that this particular city or this particular city is more in the area where the forest fire can come, and the more number of claims are coming from this particular area of like this particular region where home policies are being claimed more. So accordingly, they can analyze, and they can even increase the premiums, or they can reduce their product in that particular region and increase where it is like they are generating more business income there. So right. So on government basis, so there are various fronts where regulatory systems are there. So let's like talk about one or more things. So if insurance is there, there should be some government authorities or regulators there that restricts them to not go many, like insurance is a kind of must have to every human, like at least health insurance or life insurance. So government regulates them on the basis of data that is generating by various providers, and restricts them on the basis of rates or prices they are providing. So this can be one of the government use case. And also there's a like SSN in like USA or in India, Aadhaar card is there. So this kind of identifier or human like you can say whatever the people are using, so they can have that data. So to have a better knowledge of their living index and all the things, GDP and all, they generated data and they take actions on the basis of that. So currently also that like CoWIN is the portal they are using to face the data of how many of the peoples are already vaccinated and not vaccinated or not. So this huge amount of data also, like there are 130 like crore of people we are in India, and so this amount of data is generated on government portals as well, and they are using them to analyze as well to give you better index. Coming on to the finances, so there are various sectors in finances. Some are providing loans to the people, to the business, and some are like banking systems where people like deposits their money, credit systems. So there are various things in finances coming in. So let's say we'll talk about the one that are giving loans to the people or business. So what they do is they analyze the similar kind of profile of other people's that they provided the loan, and if those people like having a similar profile are like giving their debts out and giving back their money, like loans are being cleared by them. So accordingly, they can decide like how they can give the similar person with the similar profile this amount of loan. So basically, this can be a use case with the big data in the finance use case. Automobiles, so as like one of the use cases I already told, like in autonomous cars and everything, so they are using those data. And also like in automobiles, there are various things on the manufacturing side as well. let's say if we talk about some things like aerodynamics of the car and what is speeds they can go through, and all things are there. So in automobiles, they use the data there as well. They use like analysis on the basis of that. They even like have it. So currently it's not currently we have all the automobiles with this some or other system, GPS system or everything. So Google is providing you the on the maps you can see how many people are on what location. So automobiles people manufacturers or providers also can use that data if their vehicles are going fine with that or not, or what kind of automobiles are having some more let's say failures which are causing the accidents, and also they can analyze those data and they can collect those data. There are service orders, workshops, everything. So every workshops are generating data, what parts are serviced most, like what parts are failed most, and what parts are served what more after the automobile is bought, and in what time that is failed. So this all kind of data tell them to analyze and improve their products and services. Yeah. In the same time, like in education world right now, so as you see, like we are in the COVID time, so we are doing this kind of session. It can be the one example, and everything that is generating data. So there can be multiple source of books in the on the internet. There's a lot of videos you can learn about like big data, Hadoop, Sparks, and all things. So that is all data that is present in present on you can say data is present on the education system, and they are also analyzing to improve it better. Like everything, every like semester or things are there. So even like new policies that government has introduced to have a fifth or sixth fifth or sixth standard people having programming in their career system. So it's all result of data that the industry is having requirement of that, and so they basically implemented that in education. In the retail sector, so it's like in retail sector, let's say we talk about the big bazaar. So whenever you go to big bazaar, you provide your mobile number or something that whenever you bought something, and you probably give your mobile number, and they also to fetch to have a more of the customer need. So they also provide some coupons and all your own mobile number. They also have the details of you if you are so if you are going nearby let's say big bazaar, so they can give you an offer, and this is called age recommendation, you can say. So when you are going past through a big bazaar or any other other shops or retail markets, so they can provide you a custom recommendation that this is your nearby location, and here it is coming at this offer or like that. And also in online retail market, so you can see if you have ever went through a Amazon or card or any services, and you just click on any shoes or anything, then you must have saw that particular recommendation to on other websites basically. So that uses your clickstream data and recommends you also there is multiple things going on in the backend. So clickstream data, your IPs, your everything is there, your cache value, caches, and everything is there. So that is all being used by them to recommend you again that this shoes will be better for you or like that. Yeah. Yeah. So we talked about like how big data is important in all the industries and how they are using it or how they can provide a more value with that analysis of big data. So now comes the challenges part of big data. So as we can see, like there are a lot of sources that are generating data, but how do you manage to like perform any action or process or like stream your data or whatever you are doing, right? So the first one and the obvious one is the big data. How that is growing exponentially. How will you store it in a large amount? Second will be the data that is getting exponentially in various complexity, like it can be structured, semi-structured, or unstructured. So how will you be processing it? Because with the basis of using big data, so you need to perform some processing to come up to some like action or a decision on any business, generating any business value. So that must be a processing as well. And then comes the real time. As like real time, any streaming kind of things can be a real time data. So that can be complex to analyze because it's very fast, and you need to respond it back to in like milliseconds on second. So this is one of the challenge. And this all things like some or other way are available on the hardwares and are being used with the programs on that those hardwares. So how these hardwares and programs can be managed on this huge amount of data handling? So these are all the challenges with the big data. Basically there are many other challenges as well, like security, privacy, everything that we some or other way see on the news right now. So there are more of that challenges, but like from the storing or generating values from that perspective. So we like storing, processing this kind of data challenges we have in big data. So we talked about the challenges. Now like how Hadoop or any distributed computing system comes as a solution for this particular kind of challenges. So how Hadoop and distributed system as a solution comes in and saves the day. Like we have a distributed system. Let's say this is a master and this is a slaves. Okay. And if you are doing everything on one system, let's say one CPU, so you use, I guess you are using daily on the basis of like eight cores of CPUs and like 8 GB of RAM or like that, and I guess 1 TB of data. So that is like useful in your daily to daily work. But if you are using any if you are processing any data that is in terabytes, so that won't be useful, right? So that there comes the need of like distribution. So let's say this is the file which is of around 40 terabytes of data, and that is like distributed among 4 nodes in the distributed system. So this is how like distributed system works. The files are stored, like your data is stored in various number of nodes. We call it nodes. Like each one is a compute device, each one is a storage device. So basically we call it as a node, and there should be a like master which performs or manages this all processing, or you can say storage, or every task that we perform on a distributed system should be controlled by some manager or a master, you can say master compute device, or like that. So there is a master system, there will be some slaves, and in the distributed system the data is stored in different processes, different nodes, and also the processes which are being performed. So if I talk about simple OS program, like in every operating system, so let's talk about Windows or Linux. So there is a program that is getting processed. So once a program is getting processed, there are chunks of processes that will be created in the backend. So those processes are getting your compute on like maybe round robin basis or some or other scheduler logic, right? So the same way, like there should be a logic in the manager so that it can distribute those tasks on one program, or the number of programs are there. So it can distribute those tasks to different number of nodes, and basically also once the response is there, so also combines all the response to you and shows like it executed a one program in single. So whenever you run any program on OS, or like just click on Notepad and write something, right? So there can be multiple processes that is running on the backend, but you all only are seeing like you are only doing the Notepad, like you are only writing the something on the Notepad, right? So it's not visible to the user, but in the backend, like it's everything is converted into small chunks of processor, and it happens in very fast way, like the user won't realize it. Yeah. So basically this is the idea of Hadoop or distributed system in the basic way. So now like Harsh, are you there?
Hey, hello Shivam. Hi,
Hi,
I'm here. Yeah.
yeah. Like Harsh will be continuing with the Hadoop and distributed system, and like yeah, over to you, Harsh.
Yes. So Shivam, can you just keep this slide presented? I just need 5 minutes, and then I will start with my presentation. Or maybe I'm planning to have a break of 10-15 minutes, and then we can join back. So yeah.
Sure, yeah.
Thank you so much, Shivam, for this session, and hello everyone. Respected professors from the college and all the attendees. Yeah. So quickly, let's take a break of 15 minutes, and let's join back and then continue with where Shivam had just left. Introduction to Hadoop, and importantly, we will be discussing about distributed file system, right? How Hadoop stores the data. We discussed about uh, what is a big data, and how what are the different challenges to deal with that. But still, we can see there are some big examples, big companies, how they are processing the data, and coming up with some findings. And that is where the scope of this big data challenges becomes as an opportunity, and that is where this Hadoop comes into picture, right? And by using that Hadoop, we can process the data. So we have some setup ready with us. I'm just keeping everything ready for you people, so that we can have a very good session. So I'll try for that. So if this is okay, if there's somebody from organizing team from the college, sir, is it okay to have a 15 minutes break now? Then we can continue.
Yes, sir, we can have a 15 minutes break.
Yeah.
So we
Sure.
should start at what time?
It is 2:40 now. Let's join 5 minutes before 3 o'clock.
Okay.
Okay, sir. Yeah.
Okay.
Okay. Thank you so much. Thank you.
So I request all the participants to have a break of 15 minutes and join at 5 minutes to 3.
Yeah. Thank you. Thank you so much.
Yeah, Mr. Harshvardhan, can we start?
Yes, we can start. Is my screen visible?
Yes, your screen is visible. You can start.
Yes. Okay. Then good afternoon, everyone. Once again, and welcome back to the session. As you know, from morning, ever since from morning, you have been, hearing about cloud and then big data. Some of my friends have covered some part of the cloud, and then Shivam has covered the introduction to big data and the very first introductory slide of Hadoop, like what exactly the Hadoop is. So this is the agenda, but some of the points have already been covered. So we can just directly jump to the next session. So as Shivam was mentioning, right, we have been talking about big data and what huge amount of data, variety of data, 3 to 5 different ways, the velocity, the velocity at the data is getting generated, how it has been stored, and everything. This is okay. This is one part of the story. But what is next? How it has been, used. The very important question is how this data has been used, and that is where, as I mentioned earlier, Hadoop came into picture. So it's been now more than 12 to 13 years now. Hadoop is there in the market, and it has been grown like nothing. There are so many changes, so many updates are coming every day. It takes like 8 to 9 years or 10 years to change particular system or to get into the market. But yeah, this particular thing and some of its ecosystems, I'm calling it as an ecosystem. They have changed tremendously. So let's go ahead and talk about these things one by one in detail. But before we actually start with Hadoop and to understand like what Hadoop is, is there any particular meaning with this particular name or something like that? So we will talk about that. But before that, let it be any data, let it be a huge amount of data or let it be a small amount of data. The very first thing that we need is some kind of storage, right? Until we have some storage, we cannot think about processing that data, right? We need some storage. And once you have that data stored on, let's say, your machine, very simple example, you people have been studying databases. Let's again, very simple example, some videos are there on your laptop, right, or your machine. You just play it. So that video is being available on your laptop. That means your laptop or the machine is capable of storing that data, right? It understands that data. So the data is stored there, and you have some applications. I'm talking about applications now. You have some applications by using which you can play that video and just enjoy it. That means we need two things to deal with the data. First thing is storage, and the second thing is processing the data, right? And Hadoop is having both these things combined in a very what we can say efficient way that helps the user, the client, the company, everybody to deal with this huge amount of data, process it efficiently. See, there are two aspects of it. Try to understand when it comes to big data or any data in that case, how the data has to be stored efficiently, not just stored, but efficiently. And second, how efficiently we can process that data. These are the two main components of Hadoop that you have to understand. Is there anybody saying something? There is some noise coming from somewhere. So, can somebody go on mute? Yeah. So I was talking about storage and processing of the data. But let's have one quick example. Let me ask you people question. So everybody just bring your pen and paper if it is there. Let me ask you this question. Let's say we have. I need to stop and share my screen back. Yeah. Let's say correct. Let's say is my screen visible? Is it there? Hello, can somebody confirm?
Yes,
Yes, it is.
Okay. Yeah, me in between, I'll be asking you people, so just try to respond there. So let's say you have one system, right? On left hand side, you have one big system, and the system is capable of storing whatever required amount of data you want to store. So let's say we have 1 terabyte of data. You guys understand what terabyte is, right? You know bits, bytes, kilobytes, megabytes, GB, and then terabyte, right? Let's take an example of 1 terabyte of data. And this particular system is capable of storing 1 terabyte of data. Okay, that means there is a hard disk, whatever it is, and it stores that data, right, along with operating system and everything. Now we have to consider these two things. Let's say this particular system is having 4 IO channels. Okay, what is IO channel? Can anybody quickly answer that? There are 4 IO channels. Okay, and every IO channel is capable of processing 100 megabytes of data. Making sense? Simple example. Okay. So there are 4 IO channels with this system. Let's call this system as system A. Okay. And this particular system is capable of storing 1 terabyte of data. That means it has a required storage. And the second thing is there are 4 IO channels, and every IO channel is capable of reading or transferring 100 megabytes of data, right, per second. That is per second. Sorry, I forgot to mention that. It is per second. This is very important. Now, my question to all you is, how long this system A is going to take to read this 1 terabyte of data? Can anybody try answering that? Do your calculation mathematics. 4 IO channels. 4 IO channels can read the data in a parallel, that you have to consider. And there is 1 terabyte of data, and we are talking about what speed we have is 100 megabytes per second, right? So my question to all you is, how long it is going to take for this particular system to read this data? Come on, we need the answers quickly. Share your answers in chat window. Anybody? Can anybody answer that? Uh, 10,000 seconds. Okay. Sachin is saying 10,000 seconds. Okay. Any other answer, guys? Okay. First of all, you have to convert this 1 terabyte of data. Okay. Shreyas is saying 2600 seconds somewhere approximately. Okay, so it's the speed is given in MB, the data size given is in terabytes, so you have to convert that into GB. So you know the conversions, right? 1 TB is equal to 1024 GB. Again, speed is given in MB, then again you have to multiply it by 1024. Right. So do the calculations. It is going to be around 45 minutes. Okay, you do your calculations later, but we don't have much time, so let's do not waste this. So ultimately, approximately, this particular machine is going to take 45 minutes to read this 1 terabyte of data, right? That is one thing that we understood. Now let's go to the another, right hand session of this. Let's say now we have multiple systems. Okay, simple. Okay, let's. We have 2, we have 3, we have 4, and then we have 5, right? There are 5, and not only 5, but in all we have 10 systems, okay? Now we have 10 servers, 10 systems. Earlier we had only 1, now we have 10 systems, okay? Again, we have to read the same 1 terabyte of data. So you just have to consider one thing, this 1 terabyte of data has been distributed across these 10 systems, the cluster of these 10 machines. How it has been distributed, who is going to read, how it is going to read. These are some different questions. You don't have to ask these questions or raise these questions. I mean, just hold those questions, leave those apart. Just consider all the systems are connected somehow and they are able to read the data. And there are 10 systems now, but the data size remains same. That is 1 terabyte of data. and this single machine is having the same capability, 4 IO channels to read the data, and every IO channel can read 100 megabytes per second, okay, per channel per second. Now you tell me how long it is going to take to read the data. Remember one thing, the data is equally distributed throughout the cluster. Can we have some answers? Rohit is saying 2500 seconds for the first question, then Kshitij. Any other answer, guys, for this second scenario on the right-hand side? The difference is now we have 10 different machines and 1 terabyte of data is distributed across the cluster. See, I know we have been going through the slides, so almost 60-70 part as theoretical part, but guys, try to understand, because until you do not have this fundamental things clear in your mind, there is no point in going and checking Hadoop, how it works and how we are going to execute the program or something like that. And it will be quite difficult to understand in the very initial stage. So it is very important to understand the fundamentals of what is centralized system and the distributed system. How distributed system is powerful in some of the context than the centralized system that we are trying to understand. And one thing to mention, important thing, that Hadoop is totally based on distributed system, right? Distributed processing. It's not like that whatever huge amount of data that Shivam was talking about is being processed by a single server somewhere. Let it be Aadhaar, let it be Facebook, let it be Google, Yahoo, any this big giant company. No, there is not a single server. There are multiple servers, a big Hadoop cluster is there, and that is processing that data, right? So we have to understand this, the difference between both centralized system and what we call it as a traditional system and the distributed system. Any answers for this, guys? Shreyesh, Rohit, Kshitij, who else is there for the second scenario? No answers? When I say that data has been distributed across the cluster and there are 10 machines, right? And there is 1 terabyte of data, that is 1024. Let's consider 1000 terabyte of data is there. Only 1000 GB of data is there, right? So if we divide it by 10, every machine will be having only 100 GB of data, right? Makes sense? Can I have quick confirmation, guys? Let's consider 1 terabyte is equal to 1000 GB. There are 10 machines. We have to distribute the data equally. Do not consider that 40 or 24 GB data. So every machine will be having 100 GB of data. Now, again, every machine is having 4 IO channels, 100 megabits per second speed. This particular entire cluster will take how much? 10% of this entire time, right? Earlier it was taking 45 minutes and now it is going to take approximately 5 minutes, somewhere close to that, to read the data. Now, do your calculations later. Let's proceed further. So this is the power of distributed system. But along with this power and the efficiency, there are some challenges as well, right? I will not say drawbacks, but the challenges, and those challenges needs to be addressed. And those challenges are addressed in Hadoop in a very efficient way. And that's why we are going to talk about or study this Hadoop. Yes, Radhika is saying approximately 4 minutes. Rohit is also saying somewhere 4 minutes. Yeah, thanks guys. Thanks for your answers. Yes. So the point is, this is how the distributed system works, right? But along with this, there are a couple of challenges that we should address, right? We said data is distributed equally or somewhere. Now, theoretically saying that distributed equally is very easy, but how to distribute the data equally? Who will do this job? That is one challenge. Second, what if one of the cluster goes down? Sorry, one of the instance goes down, one of the machine goes down, right? That same thing is applicable to the left-hand side system A. But since it is a big system and it has a lot of power and computations and everything, let's say it will not fail. But on the other hand side here in the distributed system, there are chances, right? Any particular machine can go down somewhere, can get disconnected. And so there is a little bit more overhead, to take care of this distributed system. So what if one of the machine goes down? You're going to, lose that data, 100 GB of data, right? If you consider this example. Then what needs to be done? Then somebody could come up with this idea of let's add more nodes the more the nodes you add to the system, there will be more administrative work. You should, take care of your cluster, and data again needs to be distributed. Somebody can say that we can replicate the data, right? Now, since you guys are not able to answer anything, let me just answer all your questions. Replicate the data, right? But still, if you replicate the data, you have to again keep track of what piece of data has been stored on which machine and how many other machines, right? And if one of the machine goes down, then we should be able to pick that data from some of the other nodes, something like that. So let's go back to the slide and continue from where we left on the slides. But I think this must have given you right, some some idea about how Hadoop is going to look like, right? So this is Hadoop. On the right hand side, you can see there is one big machine or a master machine somewhere, right? And then there are some slave machines. So one thing to understand when it comes to Hadoop, when it comes to distributed system, definitely there is going to be master and slave configuration that you need to understand. So make yourself comfortable with these concepts. In the Hadoop, as I mentioned, or any big data processing system, if you see, we need to have a storage capacity. The storage, it should be able to store the data, right? And on the other hand, I mean, the another thing that we need is the processing capacity, right? That is the MapReduce. So Hadoop has two main components. One is HDFS. HDFS stands for Hadoop Distributed File System. It is the component of Hadoop which takes care of the data, right? Which takes care of the data. It stores the data, actual storage. And then MapReduce is the processing component of the Hadoop, right? So we will see both these components quickly. So on the right hand side, you can see there is one master, and then there are a couple of slaves. There can be a number of slaves. I'll just give you a quick example. Last time when I was reading the cluster size of Yahoo or maybe Google, I don't remember exactly, but Yahoo, at that time, Yahoo was having the biggest cluster on Earth, Hadoop cluster. There were around 4,500 nodes. Can you imagine 4,500 hardware, computers, machines, whatever you call it, as a systems were connected to each other and, holding the data, and they were processing the data. And there were a lot of research going on, and now the system is available on one click only. You just have to go and click and your Hadoop cluster will be up. But let's try to understand what Hadoop is, right? So as I mentioned, so if you remember that example, what we discussed now, Hadoop stores the data in a distributed way, right? So definitely there is going to be a lot of slave nodes. Let's consider the example of these three nodes, or in this particular example on the left hand side, one on screen, there are 4 machines, right? There are 4 machines and there is one file, and that file has been stored on these machines. Now, how that file will be stored, who is going to take care of that? We'll talk about that in some couple of next slides. So don't worry about that. Just try to understand Hadoop as a service, Hadoop as a solution. So it is capable of storing the data, and this is how it is going to store the data in a distributed way. Now, what kind of data it can store? Again, there are a lot of options. You can store structured data. Structured data means what is there in traditional database management systems, right? Tabulated form data, columns and rows and keys and everything. So that is a structured data. Semi-structured data, kind of XML files or HTML, not structured but not unstructured as well. So semi-structured data and totally unstructured data. You can take an example of images, videos, Shivam talked about, and some of the other files or file formats which are totally unstructured. We just cannot open and read the data, something like that. So these are some of the basic fundamentals of Hadoop, that Hadoop provides 2 components, storage and processing, HDFS and MapReduce. HDFS is capable of storing the data, and MapReduce is capable of processing the data. Now, how efficiently it does that? Let's go and check. But before that, let's have some quick introduction to some of the other components of Hadoop, right? So main 2 components are HDFS and MapReduce. Again, in HDFS, if you see, there are 2 other components. There are 3 components. We'll talk about the third one later. But here you can see there are 2 important components when it comes to HDFS. Remember this, mark it somewhere, note it somewhere. HDFS, there are 2 more components. First one is a master node, that is a name node, and second one is a data node. Okay, and you can see there are multiple data nodes. That is, these are the slave nodes, and there is only one name node, which is a master node, right? So it's very straightforward, easy to understand. One master, couple of slave nodes, right? Who is going to hold the data? Who is going to store the data? Slave nodes, not master. But who will have this information, like how many nodes are there in my cluster? Like how many data nodes do you see on the screen? There are 3 data nodes. Which data is stored on which data node? Correct. Which data node is alive? Which data node is dead? Right? What is the address of that data node? What is happening there with that data node as of now? What is the remaining capacity of that data node? All these questions which you will be having in your mind, the answers to those questions will be there on your name node. So that is the responsibility of the name node to keep all this information about all your cluster, right? Along with its own information, right? Let's say somebody can come and store the data. How to store the data, where it gets stored, and how it divides the data, that is another question. But just try to understand very fundamental things like, okay, somebody comes and stores the data in HDFS on Hadoop, then data will be stored on data nodes, slave nodes only, and all this information, like which file it was, what is the size of the data, how many blocks are there, new concept, blocks. We'll talk about that in some time. Right, who has stored the data, all this information will be there on the name node. So name node is very important component of HDFS, and data nodes are the slave nodes which will hold the actual data, right? 2 concepts are clear. Now there are some questions. What if one of the data node goes down, gets terminated, vanishes, or lost, or whatever it is? What will happen? No big thing, because we talked about replication. I'll explain that in detail. Replication, right? There is something called as a replication. Second important term that I'm talking about from Hadoop is replication. First I talked about is block, and the second is replication. You need to understand in terms of in the context of HDFS. When it comes to HDFS, you need to remember these 2 things, very important. So what if the data node goes down? No, you don't have to worry. The data will be there on some of the other nodes, and you can just get the data. But who will tell that data node A is down and there was some XYZ data, and the data node is down now? Where can I get the data from? So that information will be there on the name node, and that is why name node is very important, and that's why it is a master node, right? So name node will redirect your request, that processing, and you can get the data from somewhere, because the data is replicated, right? Data is not replicated on the same machine, but on the different machines. There is another concept for that. So we will talk about that, track awareness. But what if name node goes down, name node goes away, name node is shut down, or there are some problems? What will happen with that Hadoop cluster? Then in this particular context, in this example, the Hadoop cluster will be down. You won't be able to do anything, no matter how powerful your data nodes are, how many data nodes are there, how big the cluster is. But if your name node is not there, then your entire system is gone. It's of no use. You just cannot say like, okay, I'll go to the data node, I'll try to get the data and process. No, you will be getting only some bulk of data, but that is of no use. You don't know which file or which data set that data belongs to, and something like that. So this is very important to understand. In HDFS, there are 2 main components, name node and data nodes. So this is what the information is. I just talked about this, right? What name node is. It is a master daemon which is responsible of keeping track of and keeping hold of all the cluster. It is very important component of HDFS, the master one. And then comes the data node. There is something called as a secondary name node as well. What this secondary name node is, as the name indicates, it is somewhere related to name node that at least you can understand, right? But is it something, if name node goes down, then this secondary name node will take care of the cluster and will become a controller or something like that, or become a master? No. There is another configuration for that. We need to understand then Hadoop 2.x and something. There you will understand these concepts. But as of now, in Hadoop 1, by the way, in the market now, Hadoop 2 is running. Nobody is using Hadoop 1. There can be very few cases. I don't know, but yeah, that is this concept is coming from there. So secondary name node will not take care of or take the control of the cluster. But what is the responsibility of secondary name node then? Then secondary name node will only be poking the name node, communicating with the name node, and keeping the track of the logs, checkpointing. You can see the very first statement. It will be getting the logs from the name node, right? Very important question now, very important point. Just pay your attention. This is very important to understand. And it's very interesting too. There is a master name node. There are a couple of slave nodes, data nodes. I said all the information about the cluster, about the data nodes is there on the name node. But even on the name node, where this data will be stored, somebody can say, of course, sir, on the machine, on that particular master node, on the name node. Yes. But where means, by that, I mean, where? On the hard disk, on the secondary storage, or somewhere else. So apart from secondary storage, we have one more storage, that is a primary memory, right? Your memory, actual memory, 2 GB RAM, 4 GB RAM, 8 GB, 16 and more than that, right? So very important point to note that name node stores all these metadata. Okay, I am not now calling this information as a metadata, data about data, right? The actual data is stored on the data nodes, and I'm talking about data about data. So all this information that is metadata will be stored on name node, but in its main memory, that is primary memory. That is it's main memory. It will not store in on hard disk. Now, why it is storing in a main memory, right? There are a couple of there can be a couple of questions. Why not on secondary storage? Now, for that, you need to understand how primary memory, that is RAM, and the secondary storage, and then cache works. What are the benefits of that? And if you want to understand Spark in a detail, you need to understand these differences and the concept. So I will not be talking about these things much, but you guys go and go through it and try to understand. But this is very important. Name node holds all this metadata in its main memory. Why? Because you can see how big the cluster is, how many data nodes are there. There is a continuous communication happening in between name node and the data node. Now, again, I'm telling you new facts of the new things from this Hadoop and this HDFS component. These data nodes are connected means what? They're connected means they are sending and getting the reply back, and they're sharing the information. Data nodes are not sharing the information among themselves. They are sharing their own status report, new concept, new term, new status report with name node. Then only name node comes to know, okay, there is this data node and so information is stored on that data node. Getting my point? Otherwise, every time that name node will have to go and poke all the data nodes. Okay, give me your status report. Give me your status report. What's happening with you? What is there? Or what are you doing? And something like that. No. Instead of that, it is better, right? All the students reaches to this faculty and ask the doubt, right? Otherwise, when your faculty is delivering the lecture and at the end when he has to ask, he cannot go to each and every student and ask, do you have any doubt? Do you have any doubt? Do you have any doubt? It is better if, and that is the efficient way, right? That is a better way. That particular student who is having the doubt will just raise his or her hand and can ask the question, and name node, that is the faculty or the master, can immediately reply and give the answer. On the similar basis, all the data nodes would be sharing their status report, their heartbeats. Heartbeat means I'm alive. They are sending the information. Yes, I am alive. I am alive. To the name node, and name node is holding that information in its primary memory. Now, why primary memory? Because this information will be stored on very short interval of time, right? After every short interval of time, 1 second, 10 seconds, that can be configured. There are different timings, but you just consider for now approximately 1 second or few milliseconds. You can imagine if that fast, if every data node is sending the data to name node and name node is capturing all the information on hard disk, then there can be so many input output operations, right? From primary memory to hard disk. Every time it has to read, update and write, and name node will burn out. That's why it holds all the information in the memory. And that is where secondary name node comes into picture. It requests the name node, you give me your main memory image as it is. What is there in your main memory as a part of name node, as a part of master. And then it keeps all this information. It keeps the logs, edit logs, and it will keep the information with secondary name node. Now, secondary name node will not keep that information in primary memory, but in the secondary storage, that is hard disk, right? You got the concept of name node, data node. A name node keeps the information in a primary memory. That information is called as a metadata. Every data node sends the heartbeat. Every data node sends the status report. How many, what information is there, which files have been stored, and something like that, right? This is all about the basic introduction to HDFS and the first component of Hadoop. Now, coming to the first point that I had mentioned, blocks. So when it comes to Hadoop, yeah, go ahead.
Sir, I have a doubt. Like,
Yeah.
every data node stores a data, and in another data node there is a replication of this data, right? So, sir, when we change data in one particular data node, how these reflections can be done in the replicated part of another data node? How its whole process has been done? The replication of changes.
Yes, very important question and very good question. Thank you for asking that question. The first thing that need to understood is Hadoop is not meant for such kind of processings. It's not a database. Try to understand. In the database, you log in, you query the data, and then you update, right, from any UI or directly through SQL or whatever it is. But same is not applicable here in Hadoop. Once the block or the file is stored in a HDFS, you cannot update it. So there is no question of updating the file. You can append to the file. You can make another copy of the file, right? But you cannot append, you cannot update that file. So since this question is not there of updating, you don't have to worry about how we can update the replications or the replicated blocks of that file, right? Because Hadoop is not meant for updation operations. We have been talking about the huge amount of data, right? That information is not meant to be updated. Shivam talked about capturing the logs and storing somewhere. Those logs which you are getting from so many different systems, so many users, are not meant to be updated, right? This is the information. Now, depending on this information, you do your processing by using MapReduce, Hive, Spark, Scoop, whatever it is, right? So you can only process the data. I mean, you process the data and come up, you can just generate some results, some findings, but you are not supposed to update the data. So that thing is not there. But is it like we cannot update the data at all? No. There is one ecosystem called as a Hive, okay? Something called as a Hive. Hive is one of the ecosystems of Hadoop. By setting some properties, you can actually do the CRUD operations, right? You can update the data, you can delete the data, you can do anything. You can delete the data anyways with any ecosystem, or you don't have to worry about any of the ecosystem. But yeah, through Hive you can do that. But directly you cannot just go and update the file and store. You will be storing the file at some another location, and that will be another copy of that file. That file name should be changed if it is in the same parent directory. Does that answer your question?
Yes, sir. Thank you.
Yeah. Great. Okay, so moving ahead, I was talking about the block. So Hadoop stores the information in a block format. So let's say there is one file. Let's say how many? 640 MB of file, and the block size is 64 MB. In Hadoop 1.x, the block size was 64 MB. In Hadoop 2.x, the block size is 128 MB. But for our understanding, we can consider 64 MB. There is no problem with that. Now, let's say you have 640 MB file with you. So when I'm saying 640 MB file, how many blocks will be there if the block size is 64 MB? Can somebody quickly answer that? 640 divided by 64. 10 blocks are there. Agree? Correct? There will be 10 blocks. I'm not checking your chats, but I know you guys must have been answering there. But yeah, you know the answers. So there will be 10 blocks. Now consider there is one file just like that, for which we have 3 blocks. You can see on the screen, right? Block A, B, and C. And they are purposely highlighted with some different color, right? Red, blue, and green. So there are 3 blocks. Now answer this question quickly. If there are 3 blocks from that file, what should be the size of the file? What is the size of each block? 64 then the size of the file should be 64 MB into 3 or 64 MB into 3, whatever the count is, less than that, right? The last block need not be 64 MB compulsorily, right? It can be 10, it can be 20, 30, 40, 60, 61, whatever MB it is. But since there are 3 blocks, that means the file size is more than 128 MB, 64 plus 64, 128 MB, and it is less than 192 MB, right? It is in between that. So let's consider there are 3 blocks, 64, 64, 64 MB. Now, how the data will be stored in HDFS, this is very important. Now, let's just go through this rack, what this rack is. So rack is just a collection of data nodes, and the racks will be at different geographical locations. Now, how many data nodes are there per rack? There are 4 data nodes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many data nodes are there in the cluster? There are 12 data nodes in the cluster. How many name nodes are there? There is 1 name node. We do not see name node here because the purpose of this slide is to just make you understand how the data or the file will be stored in HDFS. So don't worry about name node. Name node is there, and all these racks, all these data nodes are connected to that name node. Now let's see how this it is going to store the data in HDFS. So file is divided already. Now there can be a question, who is going to divide the file? User, me, because I have that file and I am going to store that file. You, not you actually. There is one HDFS user, right? Application, HDFS client, which will automatically divide this file. Actually, physically, it is not going to divide the file while sending the file, while streaming that data, right, towards the Hadoop, towards the HDFS. At that time, it will hard stop at 64 MB by calculating the end of the line, and then it will send that data, and that we will call it as a logical 64 MB block. Now let's see how it is going to store the data. So let's say first block is stored on first data node from rack 1, right? Data node 1. Now, how many replication should be there, right? We talked about the replication. So the standard replication factor in Hadoop is 3. Remember this thing. Standard replication factor in Hadoop is 3. Can we change this? Yes, you can change it. Can we make it 1? You can make it 1. But if you make it 1 and if you lose that data node, your data is lost, right? So it is not feasible to keep replication factor as 1. We should have more replication factor, 2 or 3 or 4. Can we increase it? Yes, you can increase it till 7, 8. You can increase it, but increasing more than 5 or 7 is even not required. That is sufficient. Now, first block is stored here. As I said, replication factor is 3 for Hadoop, where these two blocks will be stored, right, of the same block. So automatically that data has been replicated and it has been stored on another rack. Why not on the same data node? If you replicate the data and store on the same data node, and if you lose that data node only, you are not going to get the data back. So it is not feasible to store on the same data node. First question is gone. Second, why not on the same rack? We can store on the same rack, but there are chances that entire rack can go away, or something can happen, natural calamities or something like that. So we are directly changing the rack. We means there is one algorithm which is running. When you store the file, automatically it keeps track of these things, and it's a name node who takes this decision where to store the data and how. Data node, no, it's the name node who is taking these decisions. It's the name node which is redirecting that HDFS client. Okay, you have to store the data on data node 1 first, and then it instructs. Name node instructs, okay, after data node 1, it should go to 5, it should go to 6, and this is how the data gets stored. So for one block itself, you have 3 copies now. If data node 1 goes away, you can still get the information from 5. If 5 goes away, you can still get it from 6. But what if rack 1 and 2 both goes down, or something happened with that? Then there is no way of getting the data. But that will be a very big issue, or the natural calamity or something like that. So and that's why you can increase the replication factor and you can increase the racks and the data nodes. But more you increase the racks and the data nodes and the blocks, there will be more requirement of the storage, and that is where you will have to pay for it. Let's see how block B would be stored. It's random. It's random. You cannot just mathematically calculate it. There is an algorithm which is running behind and which is keeping track of this thing, and this is how it gets stored, right? And the third one goes like this. It is very random. You can see on node number 6 in the middle, 2 blocks have been stored. That means the blocks can be stored, but it's not the same block. Okay, it's not the same block. It's not red, it's red and blue, right? Something like that. So this is how it stores the data in in HDFS. Let's quickly go to, okay, it's already 3:30. Fine. Yeah, still we have some time. So that was all about HDFS and how it stores the data. Now this is the end of first component of Hadoop HDFS. Do we have any questions if you want to ask quickly before we move ahead with the next session? Are there any questions? Any doubts? Hello. Okay, I'll take that as a no. Thank you. Yes. So let's begin with the second component. Second component is a map reduce. But before that, you must have observed there is this slide yarn. So to understand yarn in detail, you need to understand map reduce in detail. So I'll just quickly explain you. In Hadoop 1.x, there wasn't yarn. It was only map reduce. And in Hadoop 2.x, there is this yarn. Now, what is this yarn? Yarn is yet another resource negotiator, resource negotiator, resource manager. That means some administrative kind of work it is going to do, yarn, right? So as of now, you just consider this much information about yarn, that this is something another important component, and which keeps track of all the resources, which makes sure to schedule the jobs and everything. That administrative work will be handled by yarn. Let's jump to the important component, that is MapReduce. We talked about HDFS, how it stores the data. Now we have to process that data, right? Let's go back to this slide. Now this is how the data is distributed and stored, right, across the cluster. Now we have to process this data. There is some example, and one of the example will be covered by Shivam. He'll explain about that, one of the Spark examples. So I want to process this data. Now somebody tell me, when I submit the application, now how to submit the application, what kind of processing will be there, don't worry about that. Let's consider a very simple example. We just want to find out counts of the words. This is the Hello World program everybody talks about when it comes to Hadoop. Let's say in this particular file, we just want to calculate how many words are there and how many number of time every word is coming, right? So let's say there is one text file, and in that text file, some paragraphs are there, a lot of words are there. First word is the, right? The. So I want to find out how many times this the is coming in this entire file. That is my application. And not only that word, but all the words, and it will give me the final output, something like that. So when I submit this application, I have written in Java, Spark, and whatever it is. Will all the data be processed by that application? Because we have replication factor set to 3 and there are 3 copies of all the data. Will it not be overburdening the cluster or over processing? Yes, it will not be processing all the replicated copies of the data. It will only be processing one copy of the data. But why do we have multiple copies? To make it reliable, right? That is what we discussed. And that's why the replication factor is set to 3. So it will pick one red, it will pick one blue, it will pick
I think there is some network issue.
Hello, am I audible?
Yeah, Mr. Harshvardhan, you're
Yeah.
audible now.
Sorry, I don't know what went wrong. I thought the meeting got ended. Sorry, my sincere apologies for that. I'll start again presenting. Is my screen visible?
Yes, it is visible.
Yes, correct. So coming back to the discussion, will it be processing all the blocks? No, it will be only processing the required blocks. In the middle of the processing, let's say one of the one of the data node goes away and some of the blocks are corrupted or something like that happens, then definitely it will start looking for the data from other data nodes, right? And this is where this replication coming into picture, right? Making it reliable for the processing. So yeah, this is how it works. Let's go to that MapReduce paradigm, and then we will have understanding of one example, and then we'll proceed further. Again, for HDFS, again, I'm repeating, there were two components, name node and the data node. For MapReduce, again, there are two components, job tracker and task tracker. Okay, again, important thing. Nowadays, nobody talks about MapReduce programming and writing the code in Java in the MapReduce and processing the data, because there are so many other ecosystems like Hive, there is Scoop, and most importantly, Spark, which Shivam is going to conduct the session on again. So nobody goes for MapReduce, but as I mentioned earlier, before you jump onto the Spark and understand the power of Spark and the efficiency, you need to understand this MapReduce and play around with this. And that's why I'm just trying to explain you. It will be only 5 minutes discussion, and then we will proceed further. But again, in the MapReduce, there is a master slave configuration. There is something called as a job tracker, which is a master daemon, and there are task trackers. You remember how name node and data nodes were there? Number of data nodes were there, and only one master was there, name node. Right? Likewise, there is only one job tracker and multiple task trackers are there. Now, it's very important to understand where this job tracker is running. What is the location of the job tracker? And where these task trackers are running. One thing you guys have understood is MapReduce is used for processing, right? It is the processing component of Hadoop. Okay, then who is going to process the data actually? Job tracker or task tracker? Task trackers are going to process the data because they are the slave daemons of the MapReduce.
Hi everyone. So I guess Harsh is facing some issue with the network. I'll let me check with him. Sorry for the inconvenience.
Hey, hello everyone. Shivam, would you please share your screen? I have shared the slides with you. I think there is some issues with my browser. It's getting.
Sure, Harsh. Let me zoom.
Yeah. My sincere apologies. Sorry. I don't know. For some reason, this browser is not responding. I'm getting exited from. So yeah, let's continue. So the job tracker can be there on the save name node, or it can be on the another node. But what about the task trackers, right? If you remember the right. So the task trackers should be there on the data nodes, right? Remember 3 racks? Remember those four nodes in all the racks? So the task tracker would be running on the data node. Now, why is it so? It is because if you keep your task tracker somewhere else on another cluster, and the task tracker's responsibility is to process the data when you submit the application, the example that we talked about, word count program, don't you think that the data needs to be moved or copied from the data nodes to the task tracker towards the task tracker, right? So there will be again a overhead burden, and we are talking about big data in terabytes and so, right? Yeah, this is okay. This slide, right? So moving the data towards the processing unit is not feasible. So the task tracker would be running on the data nodes only. It's another daemon of the Hadoop system. And whenever you submit the job, that task tracker will be instructed, will be given all the information, that application as well, which you have written in whatever Java, Python, whatever. And then that task tracker will read the data, will process the data, and will produce the output. Okay, another important thing. Whatever output it has produced, where will it be stored, right? It will be stored in HDFS. It will not be sent as a file towards your EY or to your location or something. No, on another no. It will be stored on the HDFS only. So everything that you do, that will be stored on HDFS. HDFS is first, and MapReduce is what. Getting my point? It's very simple. Job tracker is a master daemon. Task trackers are the slave daemons. Map, reduce, right? Map and reduce. So there are two components of it again, map and reduce. Can we go to the next slide, sir? Correct. So this is how the flow of MapReduce. Let's talk about this MapReduce flow, and then let's go and see one example. How exactly this MapReduce? Some input will be given. Let's say there is one file we want to process. Just go through the diagram, try to understand how many mappers are there, how many reducers are there, and then it is producing something, right? So it is reading the file, in the map function. So what map exactly? Map is nothing but these are the different functions, right, which are going to read the data. So map is the very first function which will read the data from the file. Then it will do some pre-processing, whatever processing you are asking it to do. So it's a programming paradigm, right? It's a framework. You just cannot go and write a program like the way we write our regular programs. There is a structured way of writing the MapReduce program that needs to be understood. It is another part of this. So all the maps will read the data. Now you see number of mappers. Right? Who is taking care of this mappers and the reducer? Task. How many mappers will be there? It depends on how many blocks are. If we consider that earlier example, we had 3 blocks: red, blue, and green. If there are 3 blocks, there will be 3 mappers getting launched. Okay, try to understand. There is a 1-to-1 map. There is one more operation of the task getting performed in the middle. I'll talk about that in the next slide. But yeah, all the number of maps will be equal to the number of maps. So mapper is the first component or the function method which is going to read the data. It will process the data and it will send the data towards the reducer. So one thing you must have understood when it comes to MapReduce, there is something called as a MapReduce and the component of MapReduce. MapReduce is the processing component. Second, in MapReduce itself, there are two or there is one structure. That first part is a mapper part, second part is a reducer. So mapper reads the data, processes the data, pre-processing, you can say, generates the intermediate result and shares these results with reducer. Reducer does the final processing, aggregation of the data, and then produces the output. Let's go to the next slide and try to understand it. Simple example. Yeah, very simple example. On the left-hand side, there is one input file. What is there in that input file? There are just keywords, right? Deer, beer, river, car, river, deer, car. What is the ultimate aim of our program? Is to calculate how many number of times that word is coming in this file, right? You can see that beer is coming 2 times, car is 3 times, deer 2 times, and river. How it is going to happen? So the very first thing that, as I mentioned before mapping, there is something called as a splitting. Again, the splitting can be explained in a detail. It will take like half of the day, but let's not go into that detail. But as you can see from the diagram, the entire file has been split, right? Entire file has been split into multiple, we can say, blocks. So why splitting happens is because physically the block, though it has been stored, right? There is a physical way, a hard stop there. But when it has to give the input to the mapper, it checks for the end of the line, right? It has to check for the end of the line, and that end of the line, let's say there is one line, and half of the line is there in the block 1, half of the line is there in the block 2. Will it be as it is process the data? No. The mapper which is processing the block 1 will check that the splitting operation. Okay, the half of the line is here and the half of the line is somewhere else in another block. It will do a remote procedure call to that block. It will get the remaining end of the line, that remaining line, and it will be transferred to the first block. This is how splitting is happening. Splitting happens. Then this mapping will be done, right? What is the ultimate aim? To calculate the frequency of the birds. So every bird is you can say tokenized. The line has been split by space. Now we have every single keyword, right? And then we are assigning value 1 to each and every one. No need to think about that why 1, why not any other value. It's simple, right? We have to calculate the count, right? Frequency of every word. So we will just assign 1, 1, 1 value, and then on the reducer side we will aggregate it, right? And then we'll get the final. Now, before we do that, there is something called as the shuffling is getting happen in the middle. So what is this shuffling? So shuffling is nothing but, you can see that all the alphabets have been arranged. Sorry, all the words have been arranged in alphabet order. And to arrange that and to give it to a particular reducer, the shuffling phase is responsible in MapReduce paradigm. So where this reducer will be running? So reducer will also be running on one of the data node only, and controlled by the task tracker. Task tracker will be taking care of that. So reducer will be running, and that reducer did not be on the same node where map is getting it. It can be there on the same node, but it will be there on the another. So all these mappers, after processing all the data and everything, will be transferring this raw data, beer 1, beer 1, car 1, whatever, to the reducer, respective reducer. Now, how this mapper will come to know where exactly this reducer is getting executed? All this information will be given and controlled by task at the data node level, at the slave level. But this has been controlled by, again, job track, right? Because it is coming from. And once the data comes to the reducer, you can see for beer 1, beer 1 for beer 1 in the first block, it has reduced it to 2. For car, it has reduced it to 3, again 2, and that's how we generate the final output. Right? So this is the overall flow of MapReduce, reading the data from the HDFS, then doing the processing and producing the output. Now, where this final file will be stored, again, it will be stored on HDFS because it will not store outside the HDFS. There is a way to store the data in S3. That is another concept, another discussion. Let's just stick to the simple concept. The output will be stored again back to the HDFS. So this is how exactly it reads the data and processes by using MapReduce paradigm. So can we go to the next slide, sir? So yeah, go to the next one. Yeah. So when it comes to Hadoop, There are two main components: HDFS, MapReduce. HDFS for storage, MapReduce for HDFS. Again, three components: name node, data node, and secondary. In the MapReduce component, again, job tracker and transparent. And then there will be MapReduce program data management. Now, I was talking about ecosystem, right? Hive and something. If you think about this MapReduce, right, you have to write your custom codes, right? You have to use those standard functions and libraries, and you have to write your own code for each and every single part. And that is where it was getting very lengthy and critical and time consuming, we can say, for the development, right? Development cycle was too long with this MapReduce. That is where some of the big companies come up with different ecosystems. Why we call these systems as ecosystem? Because they work along with something. If you just keep them away from Hadoop and try to use them, they will not perform well, because Hadoop provides the very efficient way of storing, that is HDFS. And on top of that HDFS, you can use this ecosystem. Now, what kind of ecosystem we have? The very first, we talked about MapReduce. Right, at the bottom, you can see there is this HDFS, right? The storage, it is not going anywhere. On top of that, we have a resource management, that is Yarn. We have discussed that in detail, but it's not required in this. But apart from that, whatever you see, there are some images, pictures. These are nothing but the ecosystems of the Hadoop, right? You can see MapReduce is there, then Spark, on which Shivam is going to conduct the session on. Then there is Kafka, used to get the data, streaming data from variety of different sources to HDFS. Spark is a very efficient and very hot technology in the market as of now. If you want to go for Hadoop and this thing, go for Spark, PySpark or Scala. Then for machine learning and these things, Mahout is also there. I haven't worked on Mahout, but yeah, Mahout is there. Then Solar is there, Pig is there, HBase, and there's one more component called as Hive. I think it is not mentioned here, but yeah, Hive is again an important component. And Scoop at the just below HDFS, you can see, and Flume. Scoop and Flume are the components which will help you to get the data from the outside world to the HDFS, right? Scoop is nothing but SQL. Okay, SQL, first two alphabets, SQL, and double OP means Hadoop. So SQL plus Hadoop is nothing but Scoop, which can import the data to HDFS from the outside RDBMS, and from HDFS you can export the data to outside systems, RDBMS, right? So these ecosystems, if you want to use, you need to study this separately. But the advantage here is you don't have to write the Java, the MapReduce program in the Java or Python or right? Very simple. Let's say you want to import the data from some MySQL database. One table is there, company table, and you want to import that data in HDFS for the process. You will have to write your own Java code for it, and that will take a long time. The task is very simple, importing the data, but for that you have to write your own. Instead, now there is something called as a Scoop. Just install that Scoop. Scoop will be there. You just make use of it, and you just have to fire one query, a command, and it will import the data for you. You just have to give the credentials and everything, and then you're done. That's simple. Spark, again, very efficient processing of the data. Hive is if you know SQL, you can learn Hive in some days only. Hive is a data warehouse provided by Hadoop, you can see, on top of HDFS. So you can create table, you can do whatever you want to do with the tables, just like the way you do with SQL, right? It's very simple. It's just that the syntax and the semantics are different. The working principle behind the Hive is quite different. And likewise, so that's why these ecosystems come into picture. Now, when you club all this together, that becomes your Hadoop cluster with Hadoop ecosystem. But to take care of all this ecosystem, to monitor all this, there is one more component on the very right hand. You can see Zookeeper, right? One person is standing there, which is keeping track of all the ecosystems, if they are working properly or not, or something. Yeah, that is the concept of the ecosystem. So this is all about big data, then Hadoop, then components, then subcomponents, and then this ecosystem. Out of this ecosystem, we will be explaining one ecosystem. Shivam will be explaining that. that is, yeah, this is all from. Do you guys have any questions on whatever we have discussed? I know there can be some technical questions about MapReduce paradigm, how we store the data, let's say how it processes the data. But yeah, in the interest of time, we cannot go in that detail. But still, if you have a few questions, at least this must have given you a basic idea of what Hadoop is, how we get, how it holds the data, what is HDFS, what is MapReduce, and what are these different Hadoop ecosystems which can be used for processing the data. Just for your information, I can tell you, Yahoo was one of the first companies where the Hadoop cluster was configured and launched and used. Actually, Google published 2 white papers, Google File Search, one for MapReduce, and by making use of that, Doug Cutting is the person who invented Hadoop. Actually, Doug Cutting, you can go and search. He invented this Hadoop. He was associated with Yahoo. He started working there, and there was a big cluster. They started processing the data, and then in future, in the later part, they come up with one of the tools called as a ecosystem, that is a pig, because writing the MapReduce program was very tedious task, and that's why they come up with one ecosystem that is pig. And now pig has also been made open source, and it is Apache product. Pig. Another Hive. Facebook came up with Hive, right? They invented Hive. Likewise, some of the other companies, they came up with their own tools, and which you can just go download, install, and make use of it. It's just that you need to Hadoop install there and download that. So yeah, that is all from my end. Do we have any questions?
Yeah, I had a question.
Yeah.
Could you briefly tell us one use case of big data where
Correct.
you have used
Correct.
these tools? Like how exactly you use these
Yeah.
tools? You said that MapReduce is currently not used. So which of these tools are you using?
Yes. Thank you for that question. Recently, only 2-3 weeks back, I was working on one of the use cases. I think very recently. First thing, how are we using this? Okay. No, none of the client or the company is going directly and installing this. You guys have seen cloud and how cloud is providing the things and pay on the code whenever you. So we set up this Hadoop cluster. Let's say there is one client. There is one client, SPIT college, and this SPIT college is having huge amount of students' data, faculty data, their library, everything. That data is in there. They want to have reliable. They come to Quantify. Then Quantify provides them the AWS Hadoop infrastructure. And that is one of the services called as the EMR, Elastic MapReduce, which Shivam is going to share. Then we can launch the Hadoop cluster. Shivam will actually show you how the Hadoop cluster is launched there with only 2 nodes. There is only one master node, that is name node, and another one is the data. So to answer your question, ma'am, so that Hadoop cluster has to be there. Then that huge amount of data, whatever we are calling as a huge amount of data, needs to be stored in that SDF. Right? So there will be some answer job, there will be some source system from where you will be getting the data. So in our example, SKIT would be providing the data. We will open those gates, and we will be able to actually get that data from your existing, let's say, SQL database or whatever Oracle database, from there to our HDFS. Now, how to get this data? There I can use scope of the company. So I can just tweak the logic. I will get connected to your database, and that scope command will execute, and it will take some hours because the data is huge, and it will read all the data and will store that data in HDFS. Now, one thing is done, data ingestion is. Second, we have to process this data. Now, data is stored the way I talked about this HDFS and all, data will be stored replicated. How to process this data? Now, there are these various. Now, we can make use of Hive. Now, what is Hive? Hive is just like a SQL. It's a Hive. You can say it's a data warehouse service provided by Hive. you can execute the queries, you can create the table on top of the data which is stored on HDFS. Just imagine in the database, we go and query the data and we see the table, right? In the database, it is stored. How it is stored, we don't know. But in HDFS, the data is stored at the block level, actual file, right? And on top of that, you can actually create the table. It's just that you need to know the schema of the table, right? You can create the table and you can do that. Second, which other component can be used? We can use Spark. As I mentioned, it is a very hot and very burning technology nowadays, and everybody is going after this. Spark is very efficient ecosystem, you can say, tool which can process the data very efficiently. It does not make use of the disk to store the intermediate results. It will read the data in a memory and memory only. So talking about very market-related use case, so one of our clients has a huge amount of data, almost in 5 to 6 terabytes. I mean, again, still 5 to 6 terabytes is not a huge, but for one day processing, it is a huge amount. And the data will be getting loaded on S3. S3 is another service provided by AWS, but let's not go into that detail. The data will be stored in HDFS. Data will be stored as the data is very important. The reflection factor will be 3 and 3 times the data. Now we can imagine if the amount of data is 5 terabytes and if we have to store that 3 times, the actual storage required by your Hadoop cluster would be 5 plus 5 plus 5, 15 terabytes, and even more than. So that will be there, and the requirement was they wanted to get some very important insights from the data. Now you can imagine such a 5 terabyte of data has to be processed. We need really a big cluster. We need to program it properly. And then that data needs to be read. We need to understand the use case. Okay, how many columns are there in the data, right? What kind of information actually the user is looking for, the client is looking for. For example, as Shivam was mentioning, let's say for HPIT, let's take your example. You have all the information, students' information from the India and you want to analyze this data. It looks very small amount of data, but still, for understanding, we can. We want to understand from how many different areas of, let's say, Mumbai or Maharashtra or entire India students are coming from, and what are their aggregate marks or something like that. The use case looks very simple, but when it comes to that 5 terabytes of data, right, the traditional systems will definitely, will show their power. I mean, they will not be able to process this efficiently.
Hello, Mr. Harshvardhan.
Yeah.
Sorry to interrupt you. Actually, there is a lot of disturbance in your voice. The audio is not
okay?
clear.
Is it okay now? Hello?
Yeah, better now.
Okay, thank you for that. So the use case looks very simple here, but let's say we have to process this student's information, right? And but when it comes to 5 terabyte of data or something like that of that size, then it becomes very difficult. So that is where this Hadoop comes into picture, because it is going to process the data in a distributed manner, right? And in the next session, Shivam will definitely explain you how Spark processes that data by processing some sample amount of data. So to answer to your question, ma'am, so these kind of use cases would be there. Now this is just one use case from the project. The entire goal of the project would be to get the insights, some important information from the customer. There are so many big companies in the market, right? And you must have seen whenever you visit some Facebook pages, whenever you go and check some YouTube videos, the next day onwards or after some hours, you will start getting the recommendation for similar kind of videos or the pages or the photos or something like that. How it is happening? It is happening because of such a huge processing which is going happening behind. So these clients will be having this requirement. They have the data. Client will be coming. The customer will be coming with the data. Okay, hey, I quantify. I have so and so data, but I want to get the insights out of it. And they even do not know. They will not be knowing. Okay, what kind of information is there inside? So we as a engineer, we as a data engineer, as a platform engineer, as a solution provider, we need to understand the data. It's not only about huge amount of data and this Hadoop. We need to understand the data first. Once you understand the data, you will come up with some KPIs, key performance indicators. Okay, these things can be taken out from the data, something like that. Then accordingly, we will develop the solution. Okay, how much amount of data would be coming? Is it going to come on daily basis, on hourly basis, on monthly basis, on yearly basis? How the data ingestion would be there? Then the client will say, no, the data will be coming on hourly basis, and it has to be very real time, near real time. Then we need to think, can we use Scoop? Can we directly use Spark? Can we use Kafka? Or can we use Flume? We need to work on that. We need to solve that. We need to implement something first and test it. Once we are sure, okay, Kafka is the right tool here, Kafka is going to work very well, let's use Kafka. Then we will configure Kafka for that particular use case, and then the data ingestion will start. And then we'll schedule all the jobs. So then we just have to monitor on hourly basis. It will just keep dumping the data in. So data ingestion is solved. Likewise, we'll go for the process. So this is how we deal with all the use cases. The very first thing that we need to understand is not only the size of the data, but what data it is. What things can be or information can be taken out from the data, and then the rest of the things we already discussed, like how to store and get information. So, how many different clients or companies can you make use of this Hadoop and cloud? There is no limit. There is no any boundary for that. Banking sector, insurance sector, healthcare, all the examples that Shivam has mentioned, they can come and make use of this. It is just that they need somebody who can help them with it. So, yeah, does that answer your question, ma'am? Hello, am I audible? Shivam, am I audible?
Hello.
Yes.
Yeah. So what I would like to ask is it that in Hadoop ecosystem, the tools that are currently used in Quantify are Scoop, then Spark, Kafka, or are there more like Pig and all that is also
Correct.
used?
Correct. Yeah. So as I mentioned, I'll start from the bottom. There are very few use cases and companies which are using Pig. So if somebody is planning to learn this ecosystem, don't go for Pig. First of all, you need to understand MapReduce, then go for the ecosystem. Now, when it comes to Quantify or any other company, what we are using is importantly, along with the AWS Cloud, Google Cloud, or Azure, is Spark. Spark has been used a lot. So it is a very good tool to start with. After Spark, we use Hive. Otherwise, there are some other managed services as well which can be used on cloud, but yeah, Hive is one other thing. And when it comes to ingestion, data ingestion, there are a couple of options. We can use Flume, we can use Scoop, we can use Kafka. But among these 3-4 options, Kafka has been used very, very, very much. So the top 3 priority, if you ask me, are the important components for the ecosystems, then Spark, you can say Hive, and then Kafka. And Quantify is using all of these components. Very, what I can say, at very large scale. Big Hadoop clusters are there, EMR clusters or Dataflog from Google, Databricks is also there. And see, I mean, we don't have to go and configure everything. That everything comes as a package, and we have to go and any other technical question. I think these are very important questions. We would like to answer. Any other questions about that? Where we start, how we start with the project.
Harsh, there is a question in chat. Like,
chat.
Is there any roadmap for pursuing career in big data? Any specific certification?
Yes. There are some very good certifications available in the market. So if somebody wants to start with big data, the first thing you have to start with is learn any of the programming language properly. Okay? And let it be Java, let it be Python, let it be C. Okay? Learn one of the language, and you should have a very good understanding of this. First thing. Second, learn SQL. You need to understand how SQL works, how to write the queries, how to come up with the logic. You have to understand. So these are the two building blocks. Very first. Second, then you have to start with Hadoop. What we discussed today, just an introductory part of the Hadoop. Hadoop is so big, even how it breaks the file into blocks. To understand that, it will take 2 to 3 days properly. You need to understand how the code is written and how it is going to break that file on the fly. So it will take some time. The third thing that you have to understand is Hadoop properly, HDFS, and then MapReduce. That is Hadoop 1. Then you have to study Hadoop 2, how HDFS works and how Yarn works. Yet another resource negotiation. That is next step, right? Once you are comfortable with Hadoop, then depending on the knowledge of Python or any programming and SQL, you have to start with whatever tool you want to start. Let's say you can go for Hive. For Hive, you don't have to worry about any programming. You just need to know the basic knowledge of SQL. Then you can easily write the queries in Hive. It is just that if XYZ is the syntax of SQL, PQRS would be the syntax of that. And you just have to understand, okay, how Hive works in the backend, right? The way SQL works, no. Hive works totally a different way because it's a distributed storage and distributed processing, right? And what happens is in the backend, when you write a query, select star from so and so, where you apply the where clause and everything, and again you join one or two tables. At the end, it is going to convert that SQL into a MapReduce paradigm if you want to go into that detail. So that otherwise you would have been writing that MapReduce program. Instead, you are writing a query, and that query is getting converted into MapReduce, and that is getting executed on Hadoop, right? So that will process the data and will produce. So how you can target the next. And then once you have a very good understanding of Hadoop, SQL, Python, or Java, or Scala, and Hive, and then you jump on to Spark. But if somebody is planning directly to go and start with Spark because Spark has been used a lot and it's very demanding tool there, no, that will not help you. You have to start with SQL, you have to start with Python programming language, you have to start with Hadoop, then you go for Spark or and then Kafka. Importantly, Kafka. So if you target at least this component, that will be very much enough to get started to get into the big data stuff, right? Okay, how long will it take to learn? It depends on the individual, but still, it is better to at least give 4 months, 4 to 5 months to have a very good understanding of this. Talking about the certification. So there are so many big companies which are providing the global certifications. One of them is the Cloudera. Cloudera is one of the Hadoop distribution which provides the distribution, right? You don't have to worry about how should I configure Pig, Hive, Scoop, Flume, whatnot, Spark with Hadoop and have a cluster. They will provide you the package. You just get it, install it whenever you want on cloud or on your local machine on-prem. It will be up and running for you. So Cloudera is another one company which provides the certification. And one of the big company again, another is Databricks. Databricks is actually founded by the inventor of Spark, Mark, right? Sorry, his last name. He invented Spark actually, and he also started his own company, Databricks. So Databricks is another company which provides the certification. Earlier, Hortonworks was also there, but Cloudera and Hortonworks they have merged now. Go for Hortonworks. We can go for MapR as well. MapR as well provides the certification. And if you also want to understand the cloud and the stuff, AWS Cloud, Google Cloud, Azure, they also provide this big data related certification, data specialty. You can just go and search for the certification. But what I'll suggest, before you really go for the certifications, have hands-on practice of at least 6 months or 7 months or more than that. Then only go for the certification because the certifications are costly. The minimum certification cost is 10,000 rupees to 20, 30, 40,000. So be careful with that. Any other question? Yeah. Are we good then? Okay, I think we are good. So, sir, over to you, Shiva. Would you like to continue?
Yes, Harsh. So, should we take any break or shall we continue?
Yeah, I mean, we can.
So we can continue.
Okay.
Okay. So, yes, Shiva, please go ahead. Thank you, everyone. Thank you for.
Harshvardhan, there is a question.
Yeah.
Hello.
Yeah, please.
There is a question in chat. Which is the convenient tool for conducting the practicals?
Conducting the practicals.
I think maybe at college level.
Okay, for college level. Okay.
Yeah.
Yes. Good question. Thank you, Bharti, for asking that question. What you can do, or even faculty can also help. What you guys do, students, after this session today, tomorrow, whenever you get time, go and search for Google Colab. Google Colab. So there is a freely available kind of a notebook provided by Google where you can just go and write your code in Spark, in Python, especially Spark, and it will provide you the backend system, right? You don't have to have a Hadoop cluster and everything. So at least you can start with that. Second, Databricks, right? I mentioned about Databricks. So you have to create an account, free account of the Databricks, go visit their website, and they provide you the cluster for 2 hours, right? So if you just keep working on that, the cluster will be up and running for you. But if you do not work for at least 2 to 3 hours, it will be automatically terminated. So be careful if you're storing some data on that. Do not store any personal information of any of this. But yeah, Databricks provides you the freely available cluster. You don't have to worry about that. You just log in. If you need to have internet, just go log into Databricks, create an account, go for that free learning. You can launch the cluster. Along with that, I think, but Google does not provide. Shivam, Google
Yeah,
also provides, right? 300 credits.
Yes. So AWS and Google both provides like 1 year or some credits for every services they have. So that can also be used. And on local, if you want to like do any Spark jobs running, and also if like there is like Docker container is there. So there are images directly available which contains all the configuration of Spark, Hadoop and everything that comes with a like Jupyter notebook, Zeppelin notebook. So those can be installed on your like Docker can be installed, and you can deploy that container on your local machine and use that Jupyter notebooks and all things to run your Spark jobs. That can also be an option. But sure, yeah, that will be for your less amount of data, but that will be good for the learning.
Correct. For that, you just have to make sure you have enough memory and proper configuration. Otherwise, your system will not. But yeah, that is again a very good alternative. So you guys can easily work on these tools. You don't have to pay for that. A lot of freely available options are there. So you can quickly start with that. Thank you. Is there anything else? Okay. Yes, sure.
Okay. Yes. So like as Harsh mentioned, like Hadoop MapReduce and all, we talked about like various ecosystem of Hadoop, Apache Storm, Impala, or various things are there in the Hadoop ecosystem. So what Hadoop MapReduce is for, like it performs batch processing, like you can gather data and then process it in the batch. For like Apache Storm is one of the framework where you can use stream processing, and for Impala, Apache, so that can be used for interactive processing, and for graph processing there can be Apache Zephyr. So why Spark is so popular and being used across the industries, because it like it in a single framework have all the capabilities like batch processing. It can do real-time processing. It can have an interactive processing, graph processing, or even is the it will be a faster way of execution because it is just happening in memory. So all the processing that happens in Spark that happens in memory. Like I guess everyone is aware about the disk and the RAM, how disk and RAM work. So whenever let's say I'll just give an example of a program. So whenever a program is running, if it has to go to your disk and do some IO and get that data into in memory and then process, then it can take time. But when it goes to memory, and if your data is already present in your memory, then that IO operations will become cheap and can be performed faster, and the data can be processed faster. So these are the like features of Spark that made it like a all-rounder. So Spark is a fault tolerant. So there are mechanisms with there is a RDD concept. So I tell you in the subsequent slide. So that is just a redundant, resilient, basically resilient distributed data set. So what it makes it like fault tolerance in the backend, there are mechanisms such that it keeps replica and all things. So if one node or one worker fails out, then it can automatically manage it. It is dynamic in nature. Its reusability is more like there are multiple libraries, everything is available, and there is a big community for Spark. So everyone have a if you go to Git repository, so there are various codes available that you can reuse. There is a speed that I already told, like due to in-memory computing, it is faster. Advanced analytics, like you can do machine learning in Spark as well. There is library available for that, and you can analyze your data on the real time as well. So there is a concept of Spark streaming, so that allows that. It is like it performs a lazy evolution. So whenever you perform some transformation, it doesn't execute on the same time, and it performs on the basis of actions. Whenever you want a response or want to return something, then only it performs all the tasks. So I'll come to that later on as well. And obviously it is also allows real-time stream processing. So I just want to explain the in-memory computing. So as I told you, like whenever a program is executed, the data first fetched into the RAM and then operations are performed. So in this, like whenever a lazy evolution is done, so whenever a data is being fetched from different nodes, it will come to the RAM first and then being executed, and various operations will be performed. So that way it becomes faster. So as I said, like Apache Spark is a distributed cluster computing framework, and it's open source, so anyone can go and see the code, like and use and install it. And Spark is a data processing engine developed to provide faster and ease of use analytics. So basically, MapReduce was very, as Harsh mentioned, like whenever you need to use MapReduce, it is much of a coding. So Spark makes it easier for a developer, for a user to use it, like with various amount of libraries. There is this components there. So I'll just explain. This is basically a data storage layer where it can be HDFS, S3, Azure. It's all, these are all examples of basically a distributed data system. Then there can be data scheduler, Yarn or Mesos. It's part of a Hadoop environment, you can say. And then there is a Spark core library, which does all the tasks of Spark. And then in here, like Spark SQL structured data. So there is a Spark SQL, which allows you to query on the data that is there on the distributed system. Spark streaming in real time. So there is a library which allows you to stream data on the real time, whichever, like, let's say we can take example of Kafka, right? So Kafka is producing some data and Spark can be the subscriber of that data, and that can in real time process that or stream that data to the other end, basically. There is a MLlib library in the Spark, so that can be used for machine learning stuffs, and there is a GraphX library that can be used for graph processing. Yeah. So how Spark architecture is? It's basically the idea is the same. So there should be a master or slave in a distributed system. So the idea is the same. There is a driver program, which is basically a master, and there is worker nodes and executors, slaves are there. So on each worker node, there are executors will be there. There is a cluster manager, there is a Spark context. So how driver program works? Driver program is basically whatever the job you submit, right? So that becomes your driver program. And initially in the driver program, you need to start it with the Spark context or Spark session, and then the cluster manager will like divide all the execute tasks, and the executor will perform all the tasks. Right. So there is a concept of RDD, basically a resilient distribution data set. So why resilient? Because it is fault tolerant and is capable of rebuilding data on the failure. So basically, whenever it fails out, it keeps a copy or replication on other instances or other nodes. So that can basically easily execute that. Distributed, so the idea is the same, distributed data among multiple nodes. And data set, it's like a collection of partition data with values. So basically, it represents data that is present in distributed nodes in a one collection. So with the reference of RDD, you can use all the data that is distributed across your SDFS, across your distributed file system, and use it. So what operations are on RDD there? So there are two types of operations: transformations and actions. So as I said, like there is one more concept like lazy evolution. So whenever a transformation is performed, so it just creates another RDD, and it creates a DEG, like it's called as a directed acyclic graph. So basically, it creates a way how it will be performed when an action is called out. So let's say some transformation called as map or filter are performed on some RDD, right? So once that is done, so final RDD will be there, a DEG will be there, and whenever a action is performed, like count or something like that, collect, count, or you can save data as a text file. So basically, action is what that returns some result or data. So when it calls out, it basically execute all the RDD transformations in a directed cyclic graph manner. So it basically follows a flow and executes in a optimizer. There's another thing like data frame. So I guess you must be aware of Python pandas data frame. So that is basically one instance in memory data frame. Basically, you can say it will be, if you use a pandas in a Spark data frame, so it will come to the data will come to your one node. But when you use Spark data frame, so Spark data frame, what it does is it keeps all the data distributed, and you can use that distributed data to process all the transformation and actions. So basically, it just you can say abstraction over RDD. So RDD is there in the backend, and it performs all the you can say tabular format of transformation. So you can use Spark SQL on it. You can drop columns. You can transform columns. So basically, it's a tabular structure, and it makes it easier for a developer to perform like transformation and actions on a relational kind of data. So as I said, like lazy evolution, so it is like a whenever your Spark context is called and when you various map, filter, key by, so various transformations are performed. So basically RDDs are there will be new RDDs created, and it will become a DEG, that is directed acyclic graph, and there is a DEG scheduler in your driver program. So that schedules all the jobs and performs all the tasks in a distributed manner, in the parallelized manner. So that becomes like optimized way of execution. And then cluster manager like performs, cluster manager basically gives this task to executor, and executors will perform this task. So this in executor, this is the cache like we called that is in memory. So the data will be present in this cache whenever that is executed. Yeah. So there is Spark SQL integration, as I said, like in the initial part. So there is a Spark SQL library which allows you to query your data, like relational data on Spark, and in a distributed manner. So that is also available in here. So yeah, that is on Spark. I'll quickly walk you through a demo. So it's basically a use case where this data set is openly available, and so this data set is basically a food establishment inspection data set with a health department inspection. Basically, they want to analyze the food vendors like restaurants and other vendors to have a like inspection that it is either it is a violating their regulatory systems or not. So we want to find out the top 10 establishment with most red violation from 2006 to 2020. So let's do it on the. So before I'll just set up that. So once, let me know. Yeah, basically EMR is a managed service which provides you all the kind of big data systems. So you just have to pick some I'll show you how. Let me, yeah. So there's a cluster already created, but I'll show you how it's done. So this is EMR. If you go to advanced, in advanced options, so yeah. So this is all the Hadoop systems we talked about, right? So that Harsh explained, like Hive is there, there is a Uzi, there is a Spark, there is Presto, Zeppelin, all Scoop, all the things are that we talk in ecosystems are available in here in the EMR, and you just need to like click on the sticks, and it will launch or configure for you in the backend. So basically this is the configuration. So I'll just go to the already created one because it takes around like 25 to 30 minutes to provision. Right. So this is basically a demo cluster we created. So it contains all the application like Hive, Pig, Hue, or Spark, or different kind of let's frameworks or ecosystem, you can say. So yeah, so it's basically running on two. I will just show you. So there are two nodes. One is master, one is the master, and another one is basically a slave or worker. Yeah. So let me go to the steps. So in EMR, you can simply go to the steps. You can add steps, and you can like give it all the required things. Like I'll just explain you the Spark application, and you can give your code location. Yeah. So is my code visible to you or only the Chrome screen?
We can see the screen where you are adding the steps.
Oh, that is. So I just test it out. Yeah. So this is the one job I created, health violation. So it will find out basically that. I'll explain this job as well. So I'll just first run this. So basically I need to provide the job that is there, and I'll give arguments. So basically I kept it generic to have a data source with a there is a S3 location. S3 is basically a distributed data storage in AWS, you can say. And this is the location of the file, input file, and I'm just giving out a output location as well. So when I just click add, yeah, so it's showing as pending and it will start. So meanwhile, yeah, is it visible now on the code?
Yes, sir, it is visible.
Yeah. So
Yes.
basically, this is your main function where you just gathering your arguments and then calling out the main function that is calculating the violation. So in Spark, as I told you, like we first need to create a Spark session or context. So this statement is creating a Spark session with the application name as like calculate red health violation. So you can keep it as per your convenience or whatever the use case is. And then if data source, like if we have provided a valid data source, so I just kept a that check, and then it is reading with this Spark session that we created. So there is a Spark session, and that Spark session there is a read method on that read method with the options header true if header is present in your file, and the .csv because the file is in .csv. So there are a lot of functions like this available. So you can use that to read your files like .csv, .parquet, and yeah. So you can also learn about the Parquet or various file systems are there in the industries currently going on. So CSV is like very known to everyone, but there are multiple file systems. Parquet, ORC, or OVRO. So that makes this systems like big data systems or any other system make use of Pellins more. So basically, I give you an example of Parquet file. So it stores data in a columnar formats, you can say, and whenever you need to read data, right? So you are I'm just giving you an example, like I'm doing a select on name and account, right? So I'm just using a name, so it will just go to that columns and read out all the name from that particular file, and does not go to all the row columns, and basically doesn't check that. So it becomes faster that way as well. So Spark in conjunction with Parquet makes it more faster, basically. So yeah, this data frame will be created with the read, and then I'm just creating a temp view with this data frame. And on the views, temp views, we can do Spark SQL. So as I told you, there is a Spark SQL library. You can just use spark.sql and write your query in that, and you can perform that query on your data frame that is we just created, right? And in here, I'm doing a write and write to a output location, basically the same syntax. So as told you, like the lazy evolution, right? So it is just creating a data frame, and then it's just creating a view and the select query. So all things that are there are performed on the last step, that is the write, that is performing action and returning some result, right? So in the backend, it will create a DAG and like create a optimized way of scheduling all these tasks, and basically writes basically returns your response after processing it in a distributed manner. So let's check if that is done. Yeah, so the process is completed. I'll just show you the output for the same. Yeah, you can see, right? This process is completed, and we can see logs like how it performs. So as currently we didn't print out anything, so that is not showing anything, but we can see in here Spark history server. So I'll just open it out, and I will also open S3 that's having output of this particular job. Yeah, so you can see like job output folder is created, and here we can see, yeah, so there is a success and there is a file created, CSV file created with our response. So let's see what was our response. So basically in S3, you can do S3 select. I'll just give it. Yeah, so you can see like this is a distributed system, and I just clicked on it and the result is here. So how fast it is, right? So this is your response, like subways with the total rate violation, how many like violation has been there in the subway, or whole food market has how many rate violation. So this is all you can process and things like that. So this history server is all, yeah. So this history server is you can, where you can check all your applications. So this is one of your application, right? So we triggered with the application name of calculator rate health violation, and you can see that this is a Spark user is Hadoop and all. We can just go in here. Yeah, so this basically job you can see like converted into three tasks, three jobs, and these three jobs are distributed and completed on separately, and we receive the response. Yeah, so this all like this history server, everything. If you go with any Spark like installation or everything, right? So it comes all with them. So you can have a like local host and local host. There will be ports for this Spark job. So you can find out that in documentation and simply go to that particular local host and port, and you can see all this how it is going on. Yeah, so that's it, like from the demo side. Anyone have any doubt around it? Okay, yeah. So thank you for attending the session, and yeah. Any questions or
Any questions?
Hello, sir. Am I audible?
yes?
Participants, please fill the feedback which is shared in the chat box. It's mandatory to fill the feedback to get the certificate. So kindly do the needful. So let us end this session by a thank you speech. Good evening, one and all. On behalf of Bharatiya Vidya Bhavan's Sardar Patel Institute of Technology, I, Harshil Tarun Kanakya, would like to thank all who have helped us in making this tutorial such a resounding success. First of all, I would like to propose hearty vote of thanks to our speakers for giving us insights of cloud computing and big data. Thank you, sir, for delivering very interesting sessions. Please accept the virtual memento from our SPIT team. The first memento is for Mr. Lalit Bhosle. Please accept it. The second memento is for Mr. Akash Mahale. So please accept it. The third memento is from Mr. Sri Hari Sunil. So please accept it. The fourth memento is from Mr. Harshvardhan Bhosle. So please accept it. And the last memento is from Mr. Shivam Somani. So please accept it. Now I would like to thank the wonderful participants who have turned up in such a great number from all around the country. Thank you very much for your active participation. Hope to see you participating in near future at SPIT. I would like to thank all the members of tutorial and sponsorship committee to work hard towards making this tutorial grand success. A big thank you to our General Chair of the conference and our Principal Dr. Bhalchandra Chaudhary, Tutorial Chair Dr. Dhananjay Kalwande, and Sponsorship Chair Dr. Surendra Rathod for guiding us throughout the process. Last but not the least, I would like to thank our gold sponsor Quantify, our technical sponsor IEEE Bombay section, our silver sponsor MathWorks, and our sponsors Suven Consultant and Technologies Private Limited, Micro Device, Safety Systems, and Skinsy. Without your contribution, this event would not have been a success. A big thank you from the entire SPIT team. Now I request all the participants to switch on the camera so that we can have a group picture. Participants, please switch on the camera so that we can have a group picture. Organizing team, kindly take the screenshot of the of your screen and please save it. I request all the participants to switch on the camera so that we can have a group picture. I request all the participants to switch on the camera so that we can have the group picture. Once again, I thank all for your cordial cooperation. One important announcement for the participants. Please fill the feedback which is shared in the chat box in order to get the certificate. You will get the certificate within 7 days on your registered email ID. Thank you so much for your cooperation.
Thank you, everyone.